Start.
Good afternoon, friends. Welcome to the session on determination of dissolved oxygen in the given sample. The sample may be either a water sample or a sewage sample. For the convenience, I am going to take water sample to determine the dissolved oxygen that is present in the water. So to begin with the experiment, we shall first understand what is the meaning of DO and why is it necessary to be present in the water. Okay. So DO, we call it as dissolved oxygen. It is nothing but the oxygen that is dissolved in water or that is present in the dissolved state in water. Okay. So as you know that there are surface sources, subsurface sources of water. Okay. So the gases that are present in the atmosphere will naturally be present in the water in one or the other forms. Especially the oxygen and nitrogen, these are present in the very less quantity because they are poorly soluble in water. So the water has got dissolved oxygen based on the temperature and pressure. Okay, so you need to find out the dissolved oxygen in the water or a given sample at a standard temperature and a standard pressure. The standard temperature we take it as 20 degrees Celsius as per the Indian climatic conditions, and the pressure we take it as 1 atmosphere. Okay, so this is about the dissolved oxygen. Now you need to understand what should be the quantity of dissolved oxygen that is to be present in the sewage or water sample. Usually the dissolved oxygen should have a minimum value of 4 mg per liter. And the acceptable limit for the domestic use is from the range of 4 mg per liter to 8 mg per liter. Suppose if it is less than that, then we say that the water is not good for consumption. In case of sewage, the sewage is going to be in a septic state. As the DO value reaches 0, we say that the sewage has reached a septic condition. So in order to understand whether the sewage is septic or not, you need to find out the dissolved oxygen present in the sewage. So here I am not going to take the sewage sample but water sample that is being used to determine the dissolved oxygen present in the given sample. To proceed with the experiment, you need to first know what are the chemicals or reagents that is being used to carry out this test. You have to first take the bottle. This bottle we call it as a DO bottle or BOD bottle with a capacity of 300 ml. You need to fill the water sample or any given sample till this point, which represents the volume of 300 ml sample. Okay. Next reagent we use is manganese sulfate solution, and the second reagent is alkali iodide azodite solution. Then you need to have sodium thiosulfate solution with 0.025 normality, and also along with that you need to have a concentrated sulfuric acid to carry out this test. Now you need a titrant that we use here is sodium thiosulfate. So this is a titrant that is sodium thiosulfate with a normality of 0.025. Okay, so with the reagents and the apparatus being ready, we shall now begin with the procedure to determine the dissolved oxygen in the given sample. The procedure goes like this. You need to take a BOD bottle and fill it completely with the given sample, which is nothing but 300 ml. To this 300 ml sample, I am going to add 2 ml of manganese sulfate solution. I hope you already know the procedure to add the solution to the given sample. So this is 1 ml. So I will add first 1 ml to the given sample. Then I will take another 1 ml of manganese sulfate solution. So with this I am going to add another 1 ml of manganese sulfate solution to the given sample. So totally we have now added 2 ml of manganese sulfate solution. So I will keep this aside and we shall now add another 2 ml of alkali solution, that is potassium iodide. Since the solution is small, you can't take it more than 1 ml at a time. So I will first take 1 ml. We shall try to take 2 ml. If it is possible, then fine. No, it is not not possible. So I will take two intervals of 1 ml sample. So this is 1 ml of potassium iodide, or we can also call it as alkali iodide azide solution. I need to add 1 more ml. Yeah. Okay. So with this we have added both the reagents, that is 2 ml of manganese sulfate solution and 2 ml of potassium iodide solution. So close this stopper thoroughly so that when you shake the bottle, the solution that is present inside the bottle will not fall off. Now shake it thoroughly by inverting this BOD bottle and observe the color carefully.
That means settle.
Okay, so we'll let it settle down for some time and then observe the color and what is the situation that we are going to obtain here. So there are two possibilities. One is either DO has to be present or DO has to be absent. So there are two conditions. If DO is absent, then you should find a white precipitation settling at the bottom of the bottle. And the second one, if DO is present, then this solution will turn a little bit brown color, and that brown color is nothing but the formation of manganese oxide. Okay, so we shall wait for some time and then find out what is the situation here and then proceed with the next step of the experiment. So you can see that it is settling down at the bottom. So we shall wait for some more time until all the precipitates settle down at the bottom. Yeah. Now you can see the precipitate that has been settled at the bottom. Okay, so the top layer is clear and the bottom is with the precipitation. Okay, now we can conclude that DO is present because it is not a white precipitate. If there is a white precipitate, then it is a indication of absence of DO because there is no formation of manganese hydroxide. Instead, manganic oxide is formed. So we can say that DO is present in the given solution. Okay. Now I need to remove this precipitate. This can be done by adding 2 ml of concentrated sulfuric acid. So you need to add this acid very carefully because it is a concentrated solution.
Direct
First I'll clean this, then we shall use the solution. Okay. Take 1 ml, another 1 ml has to be taken. So we will go for 1 ml in 2 intervals. This is 1 ml. I have added, and I will add another 1 ml of concentrated sulfuric acid. Right. Okay. So process is now complete. We have added all the reagents required. Close this bottle. Pour out any excess sample that is present. Right. So now I will clean the surface of the bottle. to remove if there is any acid being present on the surface so that it doesn't hurt me. Right? Now I need to remove the precipitate. That this can be done by thorough mixing of the solutions. Should be very careful that this stopper is closed completely and tightly so that the solution does not fall off during the process of thorough mixing. Okay, so now we have obtained a clear solution. Okay, so this clear solution is due to the removal of all the precipitate that is present inside the given sample. Now I need to take 203 ml of this solution into conical flask and titrate with the sodium thiosulfate of 0.025 and normality. Now the question arises, why I have to take 203 ml only? Why not 200 ml or 100 ml? Because in most of the cases we take the sample in the scale of 50 ml or multiples of 50. So which comes out to be around 100 ml, 200 ml like that. But here in this case we are taking 203 ml of the sample. So the reason there is a calculation of taking this 203 ml. You can see the calculations here that is being done. Okay. So this is a 300 ml BOD bottle where you have taken the sample. Due to the reagents that you have used, you need to deduct 4 ml of the sample. Okay, those 4 ml indicates the reagents that was added to the 300 ml sample. Now you need to take 200 ml of this. So for 300 ml, 296 ml will be the actual sample of the water or the one that is to be tested. So for 200 ml, what should be the sample that is to be taken to identify the DO of the sample? So in that case, when we calculate it, it comes out to be around 203 ml. So I will take 203 ml of the given sample in a conical flask and then titrate it with the solution of sodium thiosulfate of 0.025 normality. So I will take the help of a measuring cylinder. So this is a 100 ml measuring cylinder. I have taken 100 ml now. Then I have to take another 100 ml. The remaining 3 ml, I will use this tube to keep it out. I need to wash this. Because I have dipped it in a sulfuric acid solution, I need to wash this to remove any acidic residue that is left behind. Now I will take 1 ml from here. Now I need to titrate this with the help of sodium thiosulfate. Before that, I need to add 2 drops of starch indicator to the given sample. can see the color change. Now you need to titrate this until the blue color changes to colorless.
Color black.
You see the color. Okay, you have to titrate this solution now till it changes to colorless. So the initial reading is 0 and titrated to obtain the final reading, which is nothing but the solution changing from blue color to colorless. You can see the change in color. So it was very blue. Go on adding the sodium thiosulfate titrant and carry the process of titration till the color changes to colorless. Right. Just a bit more focus is required. Okay, so this is the colorless solution you can see, right? So with this the procedure is completed. We note down the final reading. The final reading is 7.8. Okay, so we have now got the final reading. Initial reading was 0, so the burette reading is 7.8. And DO is calculated with the help of this formula, that is DO is equal to burette reading into normality of the titrant into equivalent weight of oxygen into 1000 divided by 203. This is nothing but the volume of the sample that was taken to titrate with the sodium thiosulfate solution. Okay, so burette reading was 7.7 into normality of the titrant. We have used sodium thiosulfate titrant, so it is 0.025 into equivalent weight of oxygen is 8 into 1000 divided by 203. So this is going to give you the DO of the given sample. So from the value of the DO of the given sample, you have to conclude whether the DO is within the permissible range or not, or whether the given sample has got a minimum value of DO, that is 4 mg per liter or not. Okay, so this is about the brief description about the procedure that you need to carry out to determine the dissolved oxygen in the given sample. The same procedure is to be repeated for the sewage sample also. Thank you.